All right, here we have this example of the three types of toys: the trains X1, trucks X2, and cars X3. And leave it up to you to read through this to see how I came up with the what we're maximizing. So in this case, we're focusing on maximizing profit by determining the number of toys to produce. And what we want to do is write this Toyco as a dual programming problem. And with changing this to a dual, now we're going to focus on minimizing the cost of using the available operation time. In other words, treating the constraints as resources. So the first thing we need to remember is that when we have a normal max, how these are written. So we maximize our objective function, and this is subjective to our constraints, and of course our x's are greater than 0. The key here is to see that the setup is these should be less than. So that's the first thing that you want to check. We'll have some other problems where they're not, and you actually have to do a modification like multiply every number by -1. But as we can see, all of these are just fine as a less than. So this is set up as a normal max. Now when we write this as a dual, I don't know why I said dual, we're going to see that the number of decision variables, so our decision variables here are going to become the number of constraints on the dual, and then the number of constraints become our number of our dual variables, which are going to be y1, y2, and y3. So a quick way to write this, notice this is maximizing, so the dual will be minimize, and we use W instead of Z up here. And then notice that the right-hand side, these become our objective function. So we'll have 430y1 plus 460 y2 plus 420 y3. And now to write our constraints, we will be going down each one of these to get our coefficients. So subject to our first constraint will just be y1, or 1y1. So y1 plus 3y2 plus 1y3. And with this being minimized, these will be greater than or equal to. And now these values come from our objective function. So that will be 3. Looking at the next one, I have 2y1 plus, there is no y2, plus, oops, I got on the wrong line. There is no y2 here, but there is a y3, so 4y3 greater than or equal to that 2. Okay, so again, I'm just going straight down. Notice here the first constraints, y1, y2, and y3. All right, and then the last one, I have a 1y1 plus, at the second one, I'm on my second y2, 2y2, there is no y3, and greater than or equal to 5. And then of course we want to be sure and write the y1, y2, and y3 are all greater than or equal to 0. So this is just a quick way to change this from the max to the min. And once again, remember that this primal, we're we're focusing on maximizing profit, where the dual, we're looking at minimizing cost. And when you run this code, you will see that you will get the same objective function of 1350 for both of these.